Hey Barnabas Racer class, today is the day that we will add our ultrasonic sensor. I'm trying to look for, oh, here it is. Yes, our, our ultrasonic sensor. So this is the thing that's going to allow our robot to see what's in front of it and stop before it crashes. So let's go ahead and get started.
Hey guys, so here is our ultrasonic sensor. I want to point out a few things here. All right, we have 4 pins that you see here, and I'm going to turn it so you can see it. It says GND, Echo, Trig, and VCC. Okay, those are the 4 pins that we're going to have to connect to our Arduino noggin. But before we do that, I want to talk a little bit about how this thing works. Okay, so let's talk a little bit about a bat. Okay, I'm going to draw a bat here. Here's my bat. Okay, now my bat, you may know this already. The bat actually cannot really see the way that we see, right? It's actually blind. So the way that it sees is through sound. All right, so I'm going to put a over here. All right, this right here is a wall. Now the bat is trying not to hit the wall, right? So this is what happens. The bat makes a sound, okay? And it hits the wall, and what's going to happen when it hits the wall, it's going to create something you might already know. It's called an echo, and it's going to bounce back. And once it bounces back, the bat starts to think, okay? That's my little think bubble. And I'll put here plus, minus, divide, X. All right, let me make sure you can see that. So this is supposed to represent math. Okay, so he's trying to do some math. And then inside, then the bat is able to see from here to here, which is distance. All right, so that's what's going on here. The bat makes a sound, it bounces off the wall, and then he does some math in here, and then that gives distance. So that's how echolocation works. We're going to learn about that today, and let's now relate it to this guy here. All right. So if you remember, our ultrasonic sensor has 4 signals. So let's go ahead and figure out how we're going to wire up our ultrasonic sensor so that we can do all that. Okay, I got my ultrasonic sensor here. Remember, we got 4 signals: VCC, Trig, Echo, and GND. Okay, so I'm going to draw our, this will be our noggin. Okay, now we have stuff connected to this already. I'm going to leave it off this diagram so that it doesn't confuse us. Go ahead and draw our ultrasonic sensor. 1, 2, 3, 4. And then I'm going to look at this, make sure I have it right here. This one here, VCC. This one here is, I'm going to put T for trig. Then here is E for echo. And then G, then D. Okay? So now we got to figure out how to connect this to our noggin. If you remember, the noggin is going to be the brain. So remember, going back to here, okay, we had the bat needed to do some brain power, okay? So if that's the case, that means this needs to be the brain, okay? So here we go. This is your brain. Okay, let's make some connections here. So VCC, that's going to be connected to 5 volts. Okay. The GND is connected to GND on the noggin. All right, GND to GND, VCC to 5V. Okay, easy enough. Just so you remember, from the very first lesson about electronics, 5V is the plus, and GND is the minus. Okay? If we don't have a plus and a minus, it can't get power. So what this establishes here is that if we connect VCC to here, GND to here, our sensor now has power. So that's good. But now how do we still need more than just powering it up. We need to be able to talk to it. So there's two things, trigger and echo. Okay. Going back to this guy. Echo is going to be the one coming back here. Okay, so this will be echo. Now, the opposite of echo would be trigger, which is you're sending something out or pulling the trigger kind of thing. So the bat is pulling the trigger on his sound, so it's sending it out. So when it comes out, it's going to be trigger. Okay? Trigger going out, echo coming in. All right, so now that we have that, we kind of know how this works. Let's go back here. Trigger is actually going to be pin number 3. All right, pin number 3. When we start coding, this will be important, okay? Pin number 3 is trigger. Actually, when we start wiring too. So wiring and coding, we got to know. Trigger is 3. Echo is going to be number 4. Okay? Pin number 3 is trigger. Echo is 4. Now, before we start coding and then wiring, I want to kind of give you a little brain exercise. If you remember, our robot brain, our noggin, can have inputs or outputs. I want you to think, is pin 3 an input or an output? Let's see. Well, pin 3 is going to be connected to a trigger. Going back to here, our trigger, is it sending out from the brain or is it getting something in from the brain? Well, from the picture, trigger is coming out from the bat, which is in the brain's on the bat. So trigger should be output. Okay, now let's look at number 4. What is pin number 4? Input or output? If you look over here, it comes in because it is echo. Echo comes into the brain. So 4 should be input. All right. Number 3, output. 4, input. So that's going to come into play when we start coding. I want to give you a little taste of what's coming, and it's good to kind of like prepare our brains so that we better know, so it's easier for us to know what we're doing when we're starting the code. Okay, so I'm jumping around a little bit. Let me come back. So now that we kind of have some context of input and output for 3 and 4, let's first wire our robot, and then we can go from there. All right, here we go. We got our Barnabas Racer here. We have our ultrasonic sensor here. And let's go ahead and wire it up just like we had talked about in the drawing. Okay, so we've got our breadboard, all this stuff that's already on here. Remember our button and our LED and stuff. We're just going to leave that on there. You'll see why later. We're actually going to use them. All right, so let's put our ultrasonic sensor on the breadboard. So here's the key thing. We want to put it on the breadboard in a way that all these 4 pins, so that they're on their own rows. Okay? Now if we think about it, the way the breadboards work, remember, rows go side to side like this. So if I do it like this, okay, actually let me turn it so you can see. If I do it like this, all the pins are on the same row. So that means that all the pins are connected. That's not what we want. We got to do it like this. Okay, let me turn it a little bit. See? Now everything is on its own row. So, all right. And then now, check that out. You can see all the different rows. So I'm going to go ahead and take a black wire, and I want you to stick it into GND row. That's going to be this one right here. GND row. All right. Now, GND needs to go to GND. So let's look over here on our noggin and find where is GND. Oh, okay. I got one right here. So I'm going to put that in. That should be good. All right. Coming back here. That's cool. Now let's do the VCC connection. So VCC is right here, this pin, and then I'm going to go over here, put it in that row. VCC. Let me move that. You know what? I'm going to move this black wire down a little bit so you can see better. There, that's better. Okay. Now this is on the VCC row, and VCC needs to go to 5V over here on the noggin. So I'm going to move this. Let's find the 5V. Okay, well, here's the weird thing. Not the weird thing, the trouble. My 5V is right here. Okay. My 5V is right here in this red wire. It's already taken, and I only got one 5V. So do I just say I quit? It's over? Why is my life so hard? No. I can go here, follow this red wire that's already in here, and if I look over here on the breadboard, okay, I'm going, following, I'm following. Look, it goes right here to this row. Make sure we can see this here. This row right here, this is the 5V row. So I can just take this wire, okay, which is connected to VCC, which is this one right here, okay. This is my ultrasonic VCC. Okay, this wire can just go into that same row right here, because this row right here is already 5V, and that's the beauty of breadboarding, right? Whatever's on that row, they're now connected. All right, so I got that taken care of. All right. Sorry guys, I'm just like trying to figure out the best way for you guys to see everything. Okay. Next one. We got to do all right, we got those two, echo and trig. They're in the middle. So echo, let's take a yellow wire and stick it into the echo row. Okay. This is going to be echo, the yellow wire. Now this needs to go into pin number, I'm looking at my chart right now. Echo needs to go to number 3. So I got to find 3 over here. And 3 is right there. Boom. Okay. That's this guy right here. Echo to 3. And then last one, 4 is to trig. So I'm going to just leave my angle, camera angle here. And this, I'm going to take a blue wire and put it into 4. So where's 4? Right there, 4. And then this needs to go to the trig. So trig is over here. Let's take a look. Trig is this row right here, and I'm going to stick it into that row. There we go. And our ultrasonic sensor is now, I'm going to straighten it out here. It is wired up. Okay? So it's actually not too hard if you think about it. Let's just recap. First thing we have to do is put the ultrasonic sensor in, make sure that every pin is on its own row, and then we just connect those rows through the wires. Okay? The tricky thing here that we want to keep track of is that the 5V was already taken up on the noggin side, so we had to use the breadboard, and we connected 5V back here. You see my finger? That's where the 5V was. All right, so I think you guys should be able to do it, so go with it. And then now we're ready to start coding. All right, guys, I have my Barnabas Racer here. We have the ultrasonic sensor, and then all the other stuff is still connected. Still got my motors. There's also my LED here. We're actually going to be using that in a little bit. So we want to make sure we have everything connected, okay? And we have our USB here. Mine's black, yours might be blue. Either way is okay, and it's connected to my computer here. Let's go ahead and do our check so that we can start coding. All right, we have tools. The board needs to be Arduino Nano. Old bootloader for the processor, and the port. Make sure you select the right COM. COM 3 for me. Again, if you're using a Mac or a Chromebook, the port's going to look a little bit different, and so if you need to look that up, go ahead and look up the tutorial videos on connecting hardware. Alright, so once that's connected, let me check here. Okay, cool. Now I'm going to do a upload by clicking here, just to make sure that everything is says done uploading. Cool. Okay, so I just uploaded a blank code. All right, so I'm going to move this over and give us some more room here. Okay. All right, so here's what we need to do. So we're going to start doing some coding here for the ultrasonic sensor, and I'm going to set up some variables here. Kind of just follow along. I'm going to explain as I'm doing this, okay? So I'm going to type int trig equals 3. So this is a variable called trig, and we're going to set it to 3. Okay? If you kind of remember trig, we connected the trig signal from the ultrasonic to pin number 3 on the noggin. So that's why it says 3 there for trig. Then we're going to make another variable, and we're not going to call it trig. We're going to call it echo equals 4. And if you remember, the echo pin on the ultrasonic sensor was connected to 4. Okay, cool. That's good. And then now I want to create some more variables that we're going to use later. Okay, I'm going to write a comment in here. I'm going to write the word float. So you might ask, what is float? Floating in the water? No, that's not what we mean here. Float, in terms of robotics or coding, has to do with decimals. So we're going to actually be doing some math right now so that we can use the information that the ultrasonic sensor gives to us so that we can calculate distance. Now, in order to do the math, we're going to have to use some decimals. So we have to use a float. Okay, so I'm just putting the comment. I'm not writing code yet, just the comment, float, so that we can handle, let me fix that, so that we can handle decimals. Okay, all right, cool. Now let's create our float variables. So I'm going to write float, and then I'm going to say speed of sound meters per second. Speed of sound meters per second. So what we're going to do later is we're going to use the actual speed of sound on the Earth in order to calculate distance. Because I'm just going to give a little sneak peek. Because think about it. What's going to be happening is that the ultrasonic will be sending sound out, and then it's going to bounce back off of something and come back. So one of the things we need to figure out that we need in order to figure out how far the object was is actually we need speed. We need speed of sound. Okay, so the speed of sound in meters per second, and you guys can look this up.
if you don't believe me, is 343 meters per second. If you Google it and say, what is the speed of sound in meters per second, you're going to find 343. Okay, so that's where that comes from. Then we're going to have a float duration, microseconds. All right. We're going to need it later, trust me. We're just duration, microseconds. That's how long it takes for the sound to go out and off something and then back, but in microseconds. All right. Then we have a float duration seconds. So the same thing, but in seconds now. Okay, and then we have float distance in meters. So when you start asking, well, what's the distance? How far, what's the distance from here to the object that it's trying to sense? First, you're going to find it in meters, but then meters is super long. Like 1 meter is pretty long. So what's more helpful is actually float distance centimeters. So at some point we're going to convert meters to centimeters. Okay, so we have our variables here. Right now I can already sense, maybe you're getting confused, like what is all this? It's going to make sense as we kind of go through this step by step. I want to first make sure we have these variables so that we don't have to go back to it. Okay, this will be like our little toolbox, our toolbox of variables. So we have these floats and then these ints. Okay, all right, now let's set up. We got to set up our inputs and outputs. Last time we set up, let's see, we set up a light, right? We also set up servo motors. Now we're going to set up a ultrasonic. So let's go ahead and set up pin mode, and we're going to set up the trig. So it's the TRIG, trig. This matches this. So that means when I put trig here, it equals 3. So this will actually mean 3, okay? So pin mode trig, which is actually 3. Now is trig an output or an input? Well, going back to my lesson earlier, I said trigger is going to be the output because it's going to be sending a sound out through trigger, so it's out. So output. And then now let's do the other one, not trig but echo. And notice that echo matches here, which is 4. So pin mode echo, which is 4. Echo is not an output, it's an input because it's going to trigger out and then bounce off something and then come back. So it's going to be an input. Okay. Now you may be asking, like, Coach Ed, why did you put trig comma output instead of just 3 comma output? Well, it would do the same thing in this case, but the reason I don't want to put 3 here is because a lot of times you might change up your wires. Okay, it's like something for some reason later, let's say you're experimenting with your racer and you make the wire to the trigger number 5 instead of 3. Well, it's kind of hard because, like, if you have this pin mode and you have to say you talk to pin 3 or the trig pin, like, throughout your code. Imagine there's like a bunch of commands like here, but then imagine there's like 200 lines of code. You have to go through and change every little instance of 3 and change it to 5. So you know what, let me just do this. So imagine you had like here a bunch, and this happens in code, right? Because you're going to be like using the ultrasonic all the time, and there's a bunch there, and then you change the echo to 5. You have to go in here and like fix every single one, and it's so annoying and takes forever, right? But if it said trig like that, let's imagine all these are trig now, if I had to change the pin 3 to pin 5, I just go here, change 3 to 5, and then now all of these are 5. Okay? So that's why you want to do this. It also makes your code cleaner, because anytime you change the pins, you only have to change the stuff up here. You don't have to like go into this area or into this area to change the pin number. All right, so I kind of like digress a little bit. Let me fix that. But it's good to tell you these little things, right? Because I don't want to just do things without any reason. I want to explain why it's important. Cool. All right. Okay, back to where we were. We have trig, we have echo. All right. Now I'm going to do another thing, because we need to print something on the serial. So I'll explain what that is. I'm going to put serial.begin 9600. Okay, so that's going to allow us to print something on the screen. So I'm going to actually play with that right now. Check this out. In my print loop, I can go serial.print parenthesis, and I do double quote hello, and the double quote, oh, like that. Okay, so I'm going to upload this, and you're going to see, yeah, this comes up. Just click save. You're going to see that it's going to start printing hello on the screen. Now I don't see anything. That's because I forgot to go to tools and serial monitor. Okay, I'm gonna move this up here. All right, you see it saying hello, 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 like all in one line. I can't even read that. So actually what we should do is print ln. So down here, print ln. That's gonna make a new line between every hello. Let's upload. Sweet. Now it's hello, and then they're all in different lines. Okay, so that's kind of cool, but that's not exactly what we want to do right now. But it does show you, because we actually want to, what we're going to do is we're going to print the distance that our ultrasonic senses, that our ultrasonic sensor senses right here. So not hello, it's actually going to print the distance. Okay, so let's get rid of this for now. We're going to play with that later. Okay. All right, so now we're going to walk through how to actually use our ultrasonic sensor. All right. The first step in our loop, we're going to say reset the ultrasonic sensor. Let me get rid of this comment, because we already know that. We don't need that. Okay. Now what we need to do to reset, it's like resetting your computer. In order to like start, you want to just reset so you're fresh. You don't have like other stuff on there that might mess it up. So you just want to reset. So how we do that? We do digital write trig low. So we're pulling the trig signal low, and we're using trig, remember our variable, which is equal to 3 here. We're going to pull it low, and then we're going to say a delay microseconds 5. So what we're telling it, we're going to say pull the trig low, and we're going to wait there for 5 microseconds, which is pretty quick, so you don't need that much time to actually reset your ultrasonic sensor. But now that it's reset, cool. Now you're ready to send out a signal over out from the ultrasonic sensor in order to detect a wall. So my next comment is going to say, here, let me make some more room here. My next comment is going to say, send a 10 microsecond pulse out through the trigger. Okay, I'm gonna make some more room here. So what is a pulse? A pulse means this: you're gonna send it, set it high for 10 microseconds, and then bring it back low. That's gonna be a pulse. Let's do that. I'm going to digital write trig and send it high. So I'm going to turn on the trig, For how many microseconds? Well, I said it in my comment, 10. Delay microseconds 10. Okay, now after that, I'm going to bring it back low to finish my pulse. So I'm going to go digital write trig low. All right. So that's my pulse. High a little bit and then low. There's my 10 microsecond pulse. Now, I just sent out a little sound. So my Racer Ultrasonic just sent out a sound. Now I got to wait until I hear something to come back. Wait for the response and store it in duration. It will return in microseconds. Okay, I'll explain that in a second. So let's say duration microseconds. Okay, this is the same as this guy right here. So we're going to use our first float. We're going to say duration microseconds equals pulse in echo high. Okay, so what's going to happen is that once this executes, okay, it's going to create a pulse. It's going to send it out. It's going to send it out of the ultrasonic. And then the next thing that happens is that you're going to call this pulse in thing. The pulse in is going to basically wait there, and it's going to look at the echo and say, do I hear anything? Do I hear anything? Do I hear anything? So it's waiting for an echo to come back. Once it gets an echo to come back, it's going to store the time that it took between here. So at the end of here is like when we just this line executes once you finish the pulse, your output pulse. And then it's going to measure the time between here and the time that it actually hears the echo. It's going to take that time and store it into duration microseconds. All right? So now inside duration microseconds, you have the amount of time that it took between you sending a sound out and then you hearing something. So that should be helpful in finding the distance. All right? Okay, hope you're with me. We got that. Now we have to convert microseconds to seconds. So I'm going to say duration. Actually, I'll put a comment here. Convert duration to seconds. I'm going to say duration seconds equals, and remember, this is not coming out of nowhere. This is the float that we made up here. Okay? So I'm going to say duration seconds equals duration microseconds. Okay? Something. I want you to think a little bit before I give you the answer. How do I convert microseconds to seconds? Okay? There are 1 million microseconds inside 1 second. So what you need to do is take your microseconds and you need to divide by 1 million. So 1 million is 6 zeros. 1, 2, 3, 4, 5, 6. All right. That will help you convert microseconds to seconds. Okay, I know we're doing a lot of math, but you're hanging in with me. I want to make sure that you guys see robotics and math, they're one. We need it. Okay, all right. So now we have the duration in seconds. Now, this is where it gets interesting, I think. Okay, we got to get the distance traveled in meters. Okay? Now, how do you do that? Well, distance equals speed times time. Did you know that? If you didn't know that, you can Google it, find out. Distance equals speed times time. Well, I have those things. Check it out. Distance meters equals duration seconds, because That's my, well, actually, you know what? I'm not going to do that one first because it might be confusing. Reset. Distance meters equals speed. So what's my speed? Well, I'm looking at the speed of sound because that's the thing that's going back and forth. When I make a little pulse, it's like a high-pitched sound that's going out, just like a bat. Sound. So what's the speed of sound right here? So I'm going to do just a Control C here so I can copy that. Control C. That's the name of my float here. So that's my speed. And then to time, you just put star times time. Where's my time? I have duration seconds here. Boom. I now have distance in meters. Okay? Now, there's another thing that we need to talk about here. All right, so if I put this in here, distance meters equals speed of sound times duration seconds, is this correct? Well, this here matches this formula. But the thing I want to bring to your attention is that actually there's another thing we need to consider here. There's something off with our formula. So distance does equal speed times time, but I want you to think about the actual distance that we want to measure. Okay, so looking at my racer, let's say I have this card. Okay, this card right here. And I want to measure, this is what happens. I send a signal from here. It bounces off and then it comes back. So the distance that I'm actually calculating, if I do it like I have right now, if I use the formula that I have right now, it's calculating this distance from here and the distance back here. So it's calculating here and back, like a round trip, here and here. That's not what we want. We just want the distance from here to here. Okay, I'm going to explain it one more time just because I know that, I want to make sure we get this, all right? Right now, it's calculating the time it takes for a sound to get from here to here and then back to here. So if we use that, the distance that we actually, the distance that the sound travels is actually here to here and then back to here. But that's not the distance we want. We just want the distance from here to here. Boom. Okay, so what does this mean? That means we have to take it and divide it by 2. Because we only want half of the distance traveled. Because the thing went out and then it came back like a round trip ticket, right? But we don't want the round trip distance. We just want the one-way distance. So we just take that and divide it by 2. So actually I'm going to update our formula. And we're going to say distance equals speed times time divided by 2. So I have to fix it down here because that's just my comment. I'm going to take these two things divided by 2. Okay? All right. Now, we have distance in meters, but remember meters is like super long. So I want to make it into centimeters. So I'm going to say convert to centimeters. So that is distance centimeters equals, all right, let's see if you can do this. How do I convert meters to centimeters? Well, there are 100 centimeters in 1 meter. So you have to take distance meters times 100. All right, you might need to think about that a little bit. That's okay. It's good to think about it. All right, so now I'm going to say serial.print distance centimeters. Whew. All right. So after all that math, and it's kind of like physics too, we are able to print the distance in centimeters. Let's upload this guy. Hopefully it works. Oh, distance. It says was not declared in this scope. What that means is that it does not know what distance underscore centimeters is. Probably because I did something wrong in my variable. Let's see, up here. Oh, I didn't catch it. Maybe you guys caught it when I was typing. Maybe you're yelling at the YouTube screen saying, Coach Ed, you misspelled distance. Okay. There. Let's try. Let's upload. All right, you see it's seeing stuff on the screen now. It says like 80 something and stuff like that. All right, so now if I put my hand, you see? If I'm really close to it, 4, 3, these are centimeters here. Pretty cool. Pretty cool. You see that? I'm gonna move this back. So these are all in centimeters. It's telling the distance in centimeters. Okay. All right. So what you see there's like 3,000 something. It's when it's too far and it doesn't sense anything in the way, it kind of throws out these huge numbers. So just something to keep in mind. Okay, I'm kind of moving it so it's right now it's hitting an object that you can't see, but it's 80 something centimeters away. Okay, so now let's do something. Let's write a simple code to make the light right here, my LED, turn on if I'm less than 5 centimeters away. All right. So how are we going to do that? Well, there's different things you could do, but one thing I want to do is I want to put all this code right here into a special function called ultrasonic. Okay, so I'm going to say float ultrasonic. Okay, boom. So inside float ultrasonic is going to be all the code. Now, why did I put float here? The reason why is because ultrasonic is actually going to return to me the distance, which is a decimal. So that's why I got to put float. So I'm going to take all this code right here, my wonderful code. I'm going to control X. I'm going to cut it. I'm going to control V and paste it into here. Okay, cool. So now a couple things I need to change. I can leave this in here for now, distance centimeters, the serial print, because I want to see later on. I actually want to see what it's sensing, the distance it's sensing. So I'm going to leave this there. But I need to add a return distance cm. Okay, so what that means is that every single time I say I want to do ultrasonic, it's going to return to me a float, which is distance cm. Okay? All right, that's working okay. Okay, now, what if I just do this now? 0.println distance, or I say ultrasonic. I wonder if that's going to work. I'm going to try to print out the return value of ultrasonic. And because I'm doing that, let's get rid of this one here, actually. I don't need to print inside the function because I'm going to print outside here, the function. All right, so what's going to happen is going to try to print whatever the return value of ultrasonic is. Let's try that. I'm going to upload. It should do exactly what it's doing now. Let's see what happens. And looks like it's still working. Very good. Very good. All right. Now, so I put something here. It's more stable, see? If I put this object here. All right, so now I'm going to update it to say if ultrasonic is less than 5, do something, else do something else. Okay, here we go. If ultrasonic is less than 5, what do I want to do? I'm going to turn the LED on. So how do I do that? Digital right. I think it was 7, right? 7 is the LED. High. Else, so if I'm not less than 5, digital right 7 low. Okay. Now let's update. I need to set up the pin mode for 7. So let's go up here. And you know what? As I'm doing this, I'm always trying to improve my code. So instead of putting 7 down here, why don't we just say LED here? LED here. So up here I can say int LED equals 7. So the same thing we're doing with trig and echo, let's do it for LED too, right? So then I can say pin mode right here, pin mode LED, and the light is in output. Okay. I think we're good. So the LED is set up as an output. Right here our code says if the ultrasonic distance is less than 5, turn the LED on. If it's not less than 5, meaning something is further away, turn it off. Let's upload. Okay. All right, moment of truth. Let's put my hand up to it and let's see if the light turns on. Oh. You see that? Look at that. When I go like that, the light is on. And then I move away, it turns off. Go like that, light is on. Now you see it's pretty good. It's not super stable. Like sometimes it'll blink and stuff, but let's use this one. See, light is on, and then go away, it's off. So you saw that it's working, and I'm able to react to my LED. Oh, sorry, I'm able to react to my distance. I can, now, in order to make it super smooth so that you don't get this like blinking light where it's kind of on and then like might flicker or something, there's ways that we can fix that, so we can go into that next week. All right, that's all we have for now. Pretty cool. We're able to get our ultrasonic sensor coded, and we also did some advanced coding here. So if your head hurts a little bit, no worries. The more you try it, more you try and look at it, it makes sense. The cool thing about this week, though, guys, is we got to do all this math, right? And then we got to connect math to the robot. So I would be proud of yourselves. Good job. That's all I got for you.
All right. Good job. So we've gone through wiring the ultrasonic sensor and experimenting with it to see if we could get to react and turn on a light. So that's really good. So the last step next week will be to integrate our ultrasonic sensor to motion so that it can actually move, turn, and stop, and in front of obstacles and stuff. And that will be the last week. All right. So good job this week. I will see you guys next time.